Hi everyone. This is similar to the one that I did on the ellipse, except it's for the hyperbola. So once again, I decided to just have one of the foci and one directrix. And you can drag the focus, and that changes the shape of the hyperbola. For the most part, it drags the hyperbola out along the x-axis. And then I also have the eccentricity up here that you can adjust. So if you adjust the eccentricity, for the most part, it flattens out the hyperbola. So we're not going to go below 1 here, because if you go below 1, then you have an ellipse. If you're at 1, you have the parabola. And when the eccentricity is more than 1, that's when you have the hyperbola. And of course, you could go as far out here as you want, but I decided just to stop at 2. So the real question again is, if you take a point, which I have here, the white point, you can put the point anywhere that you want. When will it be on the hyperbola? Well, once again, it's about the ratio of the red distance to the blue distance. So for instance, let's say that they're equal. We can see when they're equal over here. They'll be equal when the blue and the red here meet at 0.5. So the red length is equal to the blue length. For an ellipse, you needed the ratio to be less than 1. So you needed the red length to be shorter than the blue length. It's opposite for the hyperbola. The red length needs to be greater. And not only that, but the ratio has to equal the eccentricity. So you can see when that happens over here, the red and the blue will meet at the green when the ratio of the red to the blue here is equal to the eccentricity. And you can see that that happens when you are on the hyperbola. Okay, so it's the same really. It's just that the eccentricity, this ratio, is more than 1 in this case.